Okay, so in our last video, we discussed summing arithmetic sequences. In this video, we are going to be summing geometric sequences. So we want to find the sum of the first n terms of a geometric sequence. We have a formula that we can use. And let's show that now. I actually want to try and show where this formula comes from. All right, so for the sum of the first n terms of a geometric sequence can be written as follows. Okay, this is going to be the similar notation. We're going to still use that S sub n. That's going to be equal to A sub 1 plus A1 times R, which is our common difference, plus or a common ratio, sorry, plus A1 times R squared, plus A1 times R to the third, plus dot, 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 plus A1 uh, times r to the n minus 1. Okay, notice we're stopping at n minus 1 instead of r to the n. Okay, so you should confirm that this is true by our previous examples if you want to go back and double check that. Okay, so now let's multiply both sides of this equation by r. Okay, so let's do that now. So we'll have r times s sub n is equal to we'll go ahead and distribute this r. We'll have a1 times r plus a1 times r squared plus a1 times r to the third plus dot, 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 plus a1 times r to the n. Okay. Alrighty, and so now what we're going to do is we are going to we're going to subtract this equation from our initial equation, okay? So if we subtract these two, we're going to end up with s sub n minus r times s sub n, and that's going to be equal to a1 minus a1 times r to the n. And the reason for that is that each of these other terms are going to cancel out. The only thing we're going to be left with is this a times r to the n, and we're going to have a1 by itself. Everything else is going to cancel out because we have the r values are equal. Okay, so now we can solve for s sub n. We can factor out an s sub n on the left side here, and we'll have s sub n times 1 minus r, and then we can factor out an a1 here, so this will be a1 times 1 minus r to the n. Now we can divide both sides by 1 minus r. Okay, these will cancel, and we get that s sub n is equal to a1 times 1 minus r to the n over 1 minus r. So here we actually have it. This is our formula. Okay, so if we want to find the sum of the first n terms of a geometric sequence, it's our first term times 1 minus our common ratio to the nth power over 1 minus our common ratio r. Okay, so let's go ahead and do a quick example. Let's say we have a pretty short geometric sequence and we want to find the sum of all of these. We have 4 plus 4 squared plus 4 to the third plus plus 4 to the fifth. Okay, so here we're going to have a total of 5 terms. So we have n is equal to 5. We have that our first term a1 is going to be equal to 4. Okay, and our common ratio, we're going to notice that each successive term is 4 times the previous term. So here this is going to be r is going to be equal to 4 as well. Okay, so knowing that, we can go ahead and solve. So we have s sub n, or I guess I should say s sub 5, is going to be equal to a1, which we said was 4, times 1 minus 4 to the fifth over 1 minus 4. Okay? And this is going to be equal to 4 times 1 minus 2,024. Or 1,000, sorry, it should be 1,024. Okay? And that's all going to be over 1 minus 4, which is negative 3. So simplifying this a little bit, we get 4 times negative 1,023 over negative 3. And if we calculate that, we're going to end up with 13,000 or 1,364. So the sum of the first 5 terms of this geometric sequence is 1,364. Okay, let's look at another example. Let's say that we're given, using summation notation again, we're going to sum from k equals 1 up until 6. So it'll be 6 terms total. We have 4 times negative 1/3 to the k. Okay, so if we expand this out, we write this out, it's going to be basically saying we have 4 times negative 1/3 to the first power plus 4 times negative 1/3 squared plus dot 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 plus 4 times negative 1/3 to the sixth. Okay, so this is shorthand notation for this whole sum here. Okay, so here our first term, a1, is 4 times negative 1/3, or it's just going to be negative 4/3. Okay. We have 6 terms total, so n is going to be equal to 6, and our common ratio is going to be negative 1/3, because that's the thing we're taking to, that is the number we're taking to the exponent each time. So r is negative 1/3. Okay. So using this information, we can plug everything into our formula. So we'll have s sub 6 is equal to negative 4/3, a1, times 1 minus r to the n. So we'll have negative 1/3 to the sixth. And this is all going to be over 1 minus negative 1/3. Okay? So this is going to simplify to negative 4/3 times 1 minus, if we go ahead and do the exponent here, we're going to have 1 over 729. And then if we add, if we have 1, here we have 1 minus negative 1/3, that's the same thing as 1 plus 1/3. So this would really just be 4/3. Okay. And now what we can notice is we can actually cancel these. We have to keep the negative, so we'll keep that out front. And then we'll have negative, we have 1 minus 1 over 729. That's going to be 728 over 729. So our final answer is going to be negative 728 over 729. So if you sum the first 6 terms together, you get this term, or this answer here. Okay, so this is the sum of the first 6 terms. Okay, so that should be a good short introduction to summing the first n terms of a geometric series. Hopefully that's helpful for your homework. And yeah, so stay tuned. I'm going to start posting, hopefully over the weekend. I'm going to start posting some more videos on our final review. So stay tuned for that. Have a good weekend.